All right, guys. So we're gonna move away from our order of operations for a little bit, at least today. And we're gonna start working on some 3D shape kind of stuff. On the last couple homeworks, you've had a few questions asking about faces, bases, vertices, vertex, that kind of stuff, right? So now we're gonna kind of get into it as our main focus. So our first little dot here, our first little bullet says a two-dimensional shape has the measurements of what? There's two things. So when we're talking about like a square, not quite a top and a bottom. If we're looking to find an area, area of a square, what would we?
Volume and...
Not volume.
Area.
No. All right.
Cubic square inches.
Times width.
Length times width, that's what we're looking for right there.
I said that.
Did you say it right away?
I don't know.
Now you don't know? So those are the two dimensions. We have a 2D shape or two-dimensional, that's length and width is what we're gonna work with. Now we're gonna get into 3D shapes, the kind of new thing, and it's gonna add a third dimension.
Is that width?
Width. W-I-D-T. Is that better?
Yeah.
All right. So a three-dimensional shape is going to have those same two, length and width.
And volume.
Not volume. Does anybody know what that third dimension would be?
Perimeter.
Not perimeter.
Area. Square.
All right, so if we're adding a 3D, if we're going to a 3D shape, we're going to add a third dimension to it. That means we're going to have height.
Size.
It's going to be height. So height would be that third dimension there. All right, if we go from a square to a cube, all of a sudden we have a third dimension we got to measure up. There's three different things we got to measure. So length, width, and height are the big three when we're talking about 3D shapes. So now if we get into some vocabulary stuff, you guys should be familiar with some of these, most of these. It says a blank is the bottom or main shape of a 3D figure. So if we have a cube and we set it on the bottom, what do we call that bottom? A base is what we're looking for there. And it says there are only blank or blank of these shapes. So on a cube,
What is that word? That face?
base,
Face?
base. So I think you had it, Emmett. How many bases can we have?
2, 2, and 4.
Two is one of them.
1 or 2.
One or two. All right, if we have like a pyramid, that's only going to sit on one base at the bottom, and then it's going to come to a point. What's that? A cube's going to be a little different because the base and the face are going to be the same. But if we think of like a cylinder, right? It's going to have two circles, one on top, one on the bottom, so we'll have two there. But like we said, a pyramid will just sit on that bottom and then it'll come to a point. So we wouldn't call that point base.
If we have a square and you put 1 or 2 down, would that be kind of wrong?
Nope, it's still going to have one or two, it's still going to have two bases. And then it'll have four faces is what we call those other ones. We'll get into that. So here I just said it, a blank is a flat surface on a 3D shape.
A triangle.
We don't call it the base. If it's not. The face, right? I just said it. Do you have one of those shapes, Mr. Milbrandt? One of those 3D? That might help out somewhere. All right. Now what would we call it where two faces meet? Have an idea?
It's the point.
Quite a
Two faces
point.
meet. Isn't that like running into each other?
Parallel.
A vertex would be the next one. A vertex is where three edges meet. So this one would be vertex.
Wasn't our homework this one at all?
Our homework's going to be a lot like this. So let's go back to bases a little bit. You said there's only one or two bases, right? I'm trying to do this here so it's on the video. There's one or two bases, and those bases are going to be the same. So which sides on this would be the bases?
The the two that are like this, the big of the triangle.
The big ones, right? Not the triangles, these are squares. Or you,
Yes. If we look at it, these are the triangle faces.
that's a square.
Square.
Yeah. Square. Alright? So these two sides are going to be the bases on any shape. If we look at this cone here, how many bases is this one going to have?
A circle.
This is just going to have one base, right? We'll set it on here and that'll be the base. Because this isn't the same. Like this.
Yeah, that could be a base. That's a
Who's watching How to Train Your Dragon?
This is our only base right here. Alright?
No, they're watching Lucy Park.
So do you guys see the difference? How you can have one base or two bases?
Yeah.
Alright? So now we just said a face is a flat surface on a 3D shape. So we said this side and this side are our bases. So the faces would be these other four sides
We all the same.
right here. They will all be the same in this one. Alright? So you see how this is a face and this is a base?
Yeah.
Okay.
Is it?
It does. Alright. So the next one says a blank is where two faces meet. So we said these are our faces, right?
Yeah.
So what would we call this right here where these faces meet? Corner is pretty close. We're going to call it an edge. An edge is the term we'll use in math. It kind of means the same thing, right?
Okay, when you kind of rock, you call it a corner.
We want edge here. So write edge down. That's the term we're going to use.
So we get it wrong when you put corner.
Yes, you'd get it wrong if you put corner. Alright, so we already said a vertex is where three edges meet. So if we have, here's we have three corners meeting right here. See that? How we have this edge, and this edge
Yeah.
coming to meet right here, or this face, and the base coming to meet right here. This would be a vertex. Alright? So is this right here a vertex? This edge?
No.
No.
It's an edge.
What about this?
Vertex.
Alright? What about this? What would we call this?
Edge.
We call it an edge, right? What do we call this?
Our face. Face.
How about this?
Face. Edge.
What about this corner?
Oh, vertex.
That'd be a vertex, right?
Where's the hyphen?
Alright?
Oh, wow.
So now, if you look at the bottom of the notes, we're going to be asked to label a shape. So we got all this different stuff we just talked about. What would we call this?
Face.
That'd be a face, right? So we can label this in right here, fill that in, and say face for that. What about this side and this side? What do we call those, Caleb? They would be the bases, right? Draw an arrow there and say base. What are we missing so far, Landon? We got a base and a face so far.
Edge.
An edge. So which would this be an edge?
Wait, yes.
This right here, this would be an edge?
No, that's a corner.
What do we call it?
That's an edge. No, the edge is like the straight thing that goes across.
Like this right here would be an edge?
Yeah.
Alright, so draw a line or just circle the whole thing and write edge right above that. And then Asia, what did I circle up here? What do we call those? The vertex. Alright. So we got a backside on this and we're going to label another shape. A pyramid here. Who can give me something to label on this one?
The base on the bottom.
This is the base you're saying?
Yeah.
I'd agree with that. Fill that in. And say base there. Kira, can you tell me something else we'd label on this bad boy?
Vertex on the top.
Vertex on the top. I like that. Is there any other vertexes on this thing?
Yeah.
Where at, Madison?
The bottom edge. Yeah.
Each one of these would be a vertex too, right?
Yes.
We have three faces coming to meet. So how many vertexes in total do we have on this thing? 5, right? All right, what are we still missing?
Edge.
Edge. We can pick one of these as our edge. We got one thing left.
Face.
Where would that be?
We already have that.
We have a base.
Oh,
A
face. That would be this triangle face. Like the point that, or these points that are sticking out.
Be each one of these, right?
Yeah.
That's a face or face. One base, 4 faces on the pyramid.
A triangle may have different.
Okay, not a triangle. What did we just work on?
A square. A pyramid.
Alright, we just worked on a pyramid, so we're gonna say a pyramid.
That's the same thing.
Not quite. A pyramid's different than a triangle. A triangle is just this right here. That's a triangle.
Well, same thing.
Not the same thing. Alright?
And
If you put 4 of these together and you have a base at the bottom, that makes a pyramid. But there's a big difference between the pyramid and the triangle.
you'll get it once you're in math.
A triangle would be a 2D shape, right? Where the pyramid's 3D. You see that difference?
So what does a triangle look when it's in 3D?
Like that.
It's either gonna look like a pyramid,
Why do you call it a pyramid?
Because it's what the Egypt made it.
because a pyramid has 4. A pyramid is 4 triangles with a base. That's specific to this shape right here. A triangle is just one triangle,
Why can you just call it a triangle?
because it's not a triangle.
It's your
This is confusing.
No, it's not.
All right.
You have the Egypt.
If we have 4 triangles with a base on it, we're just gonna look at it and go triangle.
No.
Yep.
All right. So you see how that's a different, just one triangle right here.
Three triangles equal, no, 4 triangles equal 1 pyramid, right?
All right. So going back to our question, it says a pyramid may have different shaped base, but always has a what on the top? A vertex, right? We just labeled that up here. So there's always going to be a vertex where these 4 points meet.
I can't see the notes from
All right. The next one says a blank has a top and a bottom base that are blank to each other.
here. We'll go back.
So what would we call this? Specifically is a cylinder, but do you know what we'd call? All right. Do you know what we call shapes like this?
Face.
We call them prisms. I don't know if you guys have heard that yet.
Prisms?
A prism.
Prisms?
Prism. P-R. I'll spell it out for you. Prism. And what makes them special is they have a bottom base, a top and a bottom base that are parallel to each other.
Where do they come up with these words from? I've never heard of these names.
They've been around for a long time. All right? So we see our 2 bases here.
Yeah.
Never going to intersect with each other, right? They're parallel.
I can't see.
Well, what are you looking at then?
Spell the word.
Oh, the word.
Parallel is on the sheet.
Yeah, man, but I can't see.
All right?
We get it.
All right. The other thing, it says this means that the bases are going to be the same size and shape. So we look here, this base is going to be the exact same size and shape as this base. You're never going to have a square up here and octagon up here. Right? That's not going to work out. So these 2 bases on any prism are always going to be the same. All right, so now on the bottom, it says draw an example. On the first one, it says parallel bases.
Does it have to be 3D?
Yep, it has to be 3D. All right. So you guys want to take a shot at drawing parallel bases?
Yes.
I can do
All right. Why don't you guys try that and we'll see what you come up with.
What do you mean by parallel bases?
All right, so we just talked about it, right? So here on this, we have a
So we
prism.
need to draw that?
You could draw this, because this has parallel bases, right?
Yeah.
There's a lot of other shapes you could draw too.
Mine looks like a can.
They're like parallel base.
I made a brick there. I'm pretty good at it. Is this good? Do I think of the text to that?
that good? Does that look like it?
Yeah, that looks good.
That does not look good.
I've seen worse, I'll tell you that.
Have you done this?
Why does my pyramid look like that? Okay, I tried my best.
I'll do the shadow technique on it. I'm doing the shadow. Get boxed like fish sticks.
Alright. So it looks like you guys all did a good job there. I'm seeing a lot of cylinders like this for parallel bases. Or some of us decided to go the route
The basics.
and draw a cube here.
Not my turn though.
Or this would be
Now I
parallel
know-
to
Now I
this.
know why you said you've seen worse.
Right? That's pretty good. Alright.
Oh.
So either of these would be fine. Caleb decided to draw his like this. Would that work?
Yeah.
Does it still have two bases that are parallel?
Yeah.
Right? So it doesn't matter which way the shape's going as long as we get two bases that are parallel. Yeah, it is. Right? It's the same as this. If we have this right here, it's still got two bases. And if we just lay it on its side, those bases don't change, right? So all those are good examples of that. Now some of us got a head start, but what do we know about a vertex? What's our definition there?
Like a triangle.
Three lines meet.
Right? Alright, so why don't you guys that haven't already try and draw a vertex.
This is impossible to draw.
And notice this time it does say on top.
This one, I think I did pretty good on this one.
Alright.
I'm feeling confident.
Better than what I'm gonna get off there.
Because I can't see from back there.
Well, you chose to sit back.
Yeah, it's nice seeing back there, but you can't see.
You can sit back there.
No, because I'm still going to sit back there. Go sit. After notes, I'll go move back there. Ouch. Technically, I do like to move best.
Yeah.
Alright. So I'm seeing a lot of pyramids. Should look something like that, right? With the big. That one went a lot better than these, huh?
Yeah,
That looks pretty good.
yeah.
So our vertex would be right there. Could also drawn a cone and just gone like that and made that shape. Made this one right here, right? This has a vertex on top too.
Yeah.
So that would work.
That was so easy. You just made a circle and just instead of you to go aerodynamics and get all these different angles, you went.
Aerodynamics, huh?
I don't even know what that is.
Alright.
That was that easy.
So as long as we have this vertex on top, we're good there. Either one of these would work just fine for that.
And what now?
If you take a regular triangle. See, you saw that vertex on top of that regular triangle.
Alright? Kinda. You're still missing a little bit of 3D. Do we have any questions on any of this stuff?
No, no.
That's what we're gonna be working on moving forward. So if anything needs to be cleared up, now's a good time for that.
What? Little quiz?
Homework. Alright.
And then I made a hole.
How many
Alright.
questions on our quiz?
We'll get to that. Let's quiz you. Caleb, what do we call this? Vertex.
Ah.
Landon, what do we call this?
A base, like no base at the bottom. It's a face.
This would be the face, right? On our cone. Alright. Landon just said base, and he said it's at the bottom, so this would be our base here. Where would an edge be on this thing?
On the outside corner.
The outside corner.
Circle.
This whole thing would be an edge, right?
That's it.
So just be one big edge all the way around. Alright.
And you got the vertex.
The vertex was the first one we talked about in it.
Oh.
Alright. What about this guy? Where would a vertex be, Emmett, since you're so obsessed with it? Just on top? This would be a vertex?
No. The other, when you turn it like,
This?
I don't know how to explain it.
On top? So
Yeah,
this?
yeah.
That wouldn't be a vertex. What would this be?
That's an edge.
That'd be an edge. What do we need for a vertex?
A base.
3 lines that many.
We need 3 of them, right? So how many vertexes do we have on this guy?
6.
6, right? We got 3 on each base. Where the faces and the base come to meet. Alright. What about this guy? Where would a vertex be here?
It's on the corner of the edges. No, not the corner.
Wouldn't be there like 12 vertexes?
12 vertexes on this would be right. We got 6 on each side. Each one of these, or 3 lines meet,
Yeah.
be a vertex. And we got 6 more on the bottom.
You got the base, you got the bases, and you got the edge.
How many bases are on this, Landon? 2. How many faces are on this?
8 or 6?
6.
6.
I'll
It's
tell
a
you an
hexagon.
octagon.
An octagon would have 8. Alright? What do we call all these?
Edges.
Alright. I think we got that down pretty good, don't you?
Yeah.
Alright.
Is this all our, is this on our, all of it up is on our first?
It's gonna be a lot of this.
Wait, so you can do that, but I don't. But I don't. Oh.
Does any of it need to be on the page?
No, Kira.
We should have plenty of room to work if you need to, but
Kira, literally none of this.
Let's go. We don't have any, what's it called? The order of operation.
We get the non-colorful ones?
that's a non-boring black and white.
I don't know, like this edge, like the graphics on it, but is that pointing to the line or the sphere?
I think that's fine.
Okay.
Do we have these like right away?
Can we start?
Go ahead and get started, yep.